Hey everybody, another example for matrix operations concerning matrix multiplication. Our example is B times C, and this goes from our prior video where we had our matrices, B and C. The first thing I need to do is compare the orders. B has an order of 3 times 2, and C has an order of 2 times 2. Again, row times column, row times column. See if we can have both of those on there. This here illustrates here m times n and n times p to where what we end up with is m times p if and only if the n's are the same value. The number of columns is the same as the number of rows, and in this case it is. This is 2 and this is 2. Therefore I can perform matrix multiplication, leaving me with a new matrix of the order of 3 times 2. The two remaining numbers give you your order. So this will be rows and this will be columns. And we can look over here at the answer since it's already written out. 3 rows, 2 columns. Okay, so for doing this, we must remember that each row first. I'm going to do each row with the first column, and then I'll move on to the next column, doing each row. So I mark my first row and my first column. So I say for my first row I have 4 times 5, and then I have a negative 3 times a negative 4, or negative 3 times 1. Sorry, I was doing a row column. So 4 times 5, negative 3 times 1. That's where I mess up whenever I do them. And I follow that pattern throughout. I'm not going to go through and explain all that. You can pause the video and be able to look and see, but what I wanted to point out is if you notice the pattern. Lightly highlight it. Once you work enough of these, you start to learn the pattern, and it does help you whenever you look back on it to see if you've messed up, and like I did in the beginning, went over and did row and row. But anyway, we multiply them together, we add them together, and this is what we end up with. We end up with a 3 by 2, and that's also a great way to check to see if you've somehow messed up. So what I would like for you to do is to pause the video, and then I would like for you to try to find the product of matrix A and matrix C, and matrix B and matrix A. And there are the matrices. That way you remember. Have them to do. Okay, so let's take a look. So matrix A and matrix C. Well, the first thing that I do is I compare their orders. I say matrix A is 2 by 3 and matrix C is a 2 by 2. And whenever I look at that column from the first and the row from the second, are they equivalent? No. Cannot perform matrix operations. And what I'll do is that let's take a look at that. So A is 2, negative 1, 1, 3, negative 2, 0. And C is 5, negative 4, 1, negative 2. Okay, so I do my first row and first column. So whenever I go to do my first row, I have 2 times 5, a negative 1 times 1, but I do not have anything to multiply 1 to. That's why no matrix multiplication can occur. That way you can actually see it versus understanding. But as soon as you do this and you see that these two aren't equivalent, the column with the row, then you can't do it. So hopefully you got that. So no matrix multiplication for that one. But B and A, I bet you we can do B and A. I wouldn't give you 2 examples where you couldn't. So B has an order of 3 by 2, and A has an order of 2 by 3. And yes, These are the same, so therefore I will have for my new matrix an order of 3 by 3. So, and remember we did A times B, and look at what we had. We had a 2 by 2. We're getting ready to do B times A, and we're going to have an order of 3 times 3. Hence another reason why matrix multiplication is not a commutative property. So B is, let's see, 4, 3, 1, negative 3, 2, negative 1. That's B. And A, 2, negative 1, 1, 3, negative 2, 0. Okay, so for what I'm doing, I'm going to look at my first row going across and my first column. So give myself some room here. So I'm going to have 4 times 2, 4 times 2, and it's row times column. A negative 3 times 3 plus a negative 3 times 3. I did that one. Now I move to my next row. Erase that. Next row. Row times column. So I'm going to have 3 times 2. Whoops, let me write that bigger. 3 times 2 plus 3 times 2 plus 2 times 3. And then I'm going to have my next row. I'm going to have 1 times 2 plus row times column, a negative 1 times 3. And if you look, see all of these are 2 and all of those are 3. Now for my next, so let me erase all of this. And I did my first column, now I have to do the same thing for my second column. So I'm on my first row, and I'm going to say 4 times a negative 1, 4 times a negative 1, plus row times column, a negative 3 times a negative 2. My next column, I'm dealing with, or my next row, 3 and 2 to this column. So 3 times a negative 1 plus 2 times a negative 2. And in my last row, I have 1 times a negative 1 plus a negative 1 times a negative 2. Again, notice my pattern. Now I'm on my last column. I'm going to start with, again with my first row, but I'm on my last column. I'm almost done. So row 4 times 1 and a negative 3 times 0. So I'm going to have 4 times 1 and a negative 3 times 0 plus a negative 3 times 0. Now I'm down to row 2. I'm going to have 3 times 1, 3 times 1, and 2 times 0 plus 2 times 0. Now I'm to my last row. 1 times 1, 1 times 1 plus a negative 1 times 0, a negative 1 times 0. And now I go through and I find each of these values. 8 plus a negative 9 is a negative 1. 3 times 2 is 6 plus 6, that's 12. 2 plus a negative 3 is a negative 1. Negative 4 plus 6 is 2. Negative 3 plus a negative 4 is a negative 7. Negative 1 plus 2 is 1. 4 plus 0 is 4. 3 plus 0 is 3. 1 plus 0 is 1. And it is a 3 by 3. And that is matrix multiplication. Again, I hope that you see that, whoops, and to also make sure that I point out, see the same pattern. Discerning the pattern, and you can see across here that it was 431, 431, 431. Okay, but in negative 3 to negative 1, negative 3 to negative 1, negative 3 to negative 1 is being able to make sure that you're lining up the rows with the subsequent column and following the pattern. The math behind it is not difficult. All right, ladies and gentlemen, watch your publisher's videos, critically think and structure your homework, and good luck with your homework.